welcome back to the channel. I'm here to talk about my new project, but before that, I'm going to explain where I've been. Working full-time is where I've been. Not coding, sadly, but working nonetheless. It's been taking up a lot of my time, and so I haven't had time to code. Um, but I'm back now, and I want to code. So, quick update on where my last project, Mall Massacre, went. It's done. Like I said in the last video, I planned on writing a document about what I learned and everything, but um, I'd much rather get this project started than focus on that. So yeah, that's where I'm at. That's where we're at with the project. Um, yeah. What is ATGE? Here's a quick overview. ATGE, or the Almost Total Game Engine, aka project please hire me, Creative Assembly, please Creative Assembly, please hire me, please, is going to be my take on what a Total War real-time strategy game engine might look like. So it's going to be a game engine built specifically to create games like the Total War games, specifically more like um, Medieval 2 Total War, Rome Total War, the kind of old classic games, not the more modern ones, to replicate the kind of like campaign map, having units, cities, movement, like armies moving around, and then battles with like hundreds, maybe thousands of units going at it. Um, my goal is to replicate that. Um, Obviously, I'm one person, and they have a whole team, and are using much more modern techniques than I will be using. But that's the goal. I'm going to build the project using C++, obviously. I'm going to use DirectX 12 for the graphics API. I'm going to use async to load the models. I'm going to use Erclang to handle the audio, and then Clay to handle the UI. I will put an asterisk next to the Clay because I haven't actually played around with it yet, and it might fall apart on me. Not sure. We'll see. So, the objectives of this project. Obviously, first and foremost, I want to learn. Um, my goal in life, I guess, is to be an engine/graphics programmer. And I think making an engine in a genre that I love, real-time strategy games, Total War games, I think it will help motivate me a lot to actually do it. Here's a few things I want to practice specifically. DirectX 12, I want to learn a more modern graphics API. Multi-threading, big asterisk on that. I'll talk about it more later. I want to learn some new rendering techniques, particles, SSAO, normal mapping maybe. I want to learn how to create new game tools, game design tools, which is something that my old engine, Moab, was definitely lacking. And then finally, I want to move away from object-oriented programming and learn more about ECS and uh, memory locality and all that. And so, yeah, going to each of these different goals now. Why do I want to learn DirectX 12? So, basically, I want to learn a modern graphics API. My last graphics engine was written with DirectX 11. I want to be up to date with what people are using in the industry. So rather than jumping to something like Vulkan, which I do want to learn at some point, because it's cross-platform and all that good stuff, I feel like jumping from DirectX 11 to Vulkan is a bigger jump than DirectX 11 to DirectX 12. A kind of side goal of this project is to have it be cross-platform. That's not going to be tested in any way. It just, I want to build it in a way that is kind of cross-platform. And obviously DirectX 12 is not cross-platform. But just keep in mind that that is a thing I'm keeping in the back of my mind for this project. Next up, some rendering techniques I want to learn. So I already talked about them a little bit. Normal mapping, SSAO. I also want to work on particles. When I was working on my last game, Mall Massacre, I noticed how empty, how like kind of lifeless it felt without particles. And so I definitely want to include those this time. I also think having particles will just give me another way to flex the performance of my game engine, which will hopefully be pretty good. Um, Hopefully, fingers crossed. Yeah, so particle system, I want to have SSAO and normal mapping if possible. I doubt these things will be integrated into the final product. We'll see. But I just want them because I think they look nice. Oh, also, tone mapping is something I'm looking into doing. We'll see if it's actually done. But yeah. Um, Moving on. Okay, so something I did while I was on hiatus, I guess, from C++ programming is I was working on a Hearts of Iron 4 mod. I might make a video about that at some point, but the reason I bring it up is because I realized the way that engine worked, all the engine did was like read the files and then build the game from the files given to it. So you could, and it was super versatile. You could build almost anything, and that's what I want my game engine to look like. Basically, just reading a bunch of files that the user gives it, and then it just creates the game from that. Yeah, I think it'll have a lot of opportunities for modding, for it'll make the game design steps a lot easier, and the goal essentially will be to have it so the game programmer does ha- needs to write as little C++ code as possible. That's the goal. So yeah, finally, another thing I've been up to on my hiatus has been watching coding talks. If you know, you know. And basically, one of the things I've learned is how bad object-oriented programming can be in terms of performance, and like how it doesn't really fit with how computers actually process data. And so, by building the engine in an ECS way, and it will hopefully result in cleaner, faster code. So that's the idea. Moving on. Multi-threading. This is the part with the biggest asterisks behind it because I actually haven't done any research yet into how game engines are multi-threaded. And so that is something that will have to happen, and it's why I'm not going to touch it until I have much more background on it. Um, yeah, but just know it is a goal that into the future, at some point the engine will hopefully be multi-threaded. Um, so now that I've gone over all the objectives, here's the plan. I'm going to split the work of developing the engine into four parts. In the first part, or in the first phase, I'm going to finish all the core engine and graphics systems. So by the end of it, I should have an extremely basic ECS-driven game engine and an extremely basic DirectX 12 graphics engine with lighting, textures, model loading, UI, stuff like that. Um, it'll be extremely basic. Essentially, it'll be like what Drizzle is, maybe even more basic than that. um, just super bare bones, but ultimately functional. And if you wanted to, the goal is that if I wanted to, I could create the game right then and there with what I have so far. Create any game really with what I have so far. By the end of phase one. Then in phase two, I'm going to start integrating core game features into the engine itself. So that'll be things like game modes for RTS, less Total War games. There's really three main ones: the menu, the campaign map scene with the cities and the different armies moving around, and then the battle scene where units actually go on the ground and fight each other. It's going to have a way to edit units outside of the outside of writing C++ code. It's going to have all the features you'd expect in a battle mode. Unit selection, being able to give them orders, them actually following the orders and battling. It will have the ability to code very basic AI features, outside of having to write everything in C++. And that includes things not just like in the battles, like having basic AI for the battles, but having basic AI for the campaign. Like you'll be able to tell it how aggressively to play, how diplomatically, blah blah blah, whatever. Um, and then finally, pathfinding. This is probably going to be the biggest hurdle in this phase, I'm guessing. Um, but yeah, it'll have like grid system, A star pathfinding, all integrated directly into the engine, so that the game programmer will hopefully have to write as little C++ code as possible. Um, yeah, that's phase two. Moving on to phase three and four. Um, very vague, very um, empty. Phase three is to build the game itself, and then phase four will be to go back and integrate multi-threading and make the engine multi-threaded. Um, it's intentionally very vague and sparse here because I haven't thought that far ahead yet. My main focus is on actually building the engine and the systems, um, and then I can worry about the game. And then once I've learned more about multi-threading, I can come back and update how I'm gonna integrate multi-threading. Um, that's the overview. Let's get into phase one. Okay, so now that we've talked about ATGE and what the goals of it are and what um, the objectives of the overall project are, let's talk about phase one specifically. So, what are the objectives of phase one? Like I said, it's to have all the core engine and graphics components in place. Um, what that means essentially is it will be like a very basic Moab slash Jazul with absolutely zero game code and like as bare bones as it can possibly be. Um, yeah. So, what is the architecture of this going to look like? Um, Basically, there's going to be four layers: the core layer, the rendering layer, the engine layer, and then the game layer. We're not going to touch the game layer. Engine layer, it's going to be a little bit of work in the engine layer, but not as much because a lot of the game tools or like a lot of the game specific code is going to be put into the engine layer eventually. So really, what's happening here is like maybe half of the engine layer, complete rendering layer, and a complete core layer. Um, so moving into each of these layers or components specifically, um, ECS, the entity component system, the minimum requirements are here. You can stop and read it, but essentially it will be every entity will be tracked by a unique ID. It will be stored tightly in memory to ensure that the engine is as efficient as possible when it reads the memory because it'll all be close together. And then all the memory will be managed by a memory manager so that there are zero heap allocations during the runtime of the engine or the game, and that all the memory used by the engine slash game will be pre-allocated and like fit within a very small slice of memory essentially. Moving on to the graphics engine, here are the minimum requirements for that. Obviously, I have to be using DirectX 12. Um, it has to like start up, work, run uh, efficiently without errors. Um, I'm gonna use frame resources to simplify the because if you don't know DirectX 12, there's a fence you have to put up because everything is manual, and I'm gonna simplify it through frame resources. Anyway, this isn't the DirectX 12 tutorial. Um, it's gonna have mesh rendering, like I said, through the async library. It's gonna have instance rendering because you definitely need that for these large battles that are hopefully, fingers crossed, gonna be taking place with the engine in the game. The lighting and the shadows, it's going to use the Phong lighting system just because that's what I use for Moab. This isn't really a project to work on lighting. So the light culling is going to be the same as in Moab. CSM, PCF, all of it's going to be exactly the same as no like improvements here from Moab. Um, I'm just essentially porting that code over and updating it to DirectX 12. Some other stuff. The obviously textures are going to have to work. Particles, SSAO, ACEs, maybe. Um, it has to be scalable. It has to be like, structurally sound. Obviously, these are just like with any project. It should be this way. Um, Finally, any other systems? Like I said, I said earlier, uh, making it cross-platform is like a tiny mini goal. I'm not actually going to test it in any meaningful way, but it will be designed in a way so that theoretically anyone could just branch off of my code and create a Vulkan version or a OpenGL or DirectX 11 version. Um, but that's not a super hard goal. The math library, I'm gonna use the same one I used for Moab and Jazul. I just have to update it, but that's like again another goal. Audio, I'm gonna be using Erklang like I use in Moab. I just need to update it for the new ECS system. So now let's get into each of these sprints. To clarify, each sprint is going to be like about the goal is to finish in about 2 weeks, and then and then the goal is to have 10 sprints. We'll see how well that goes, but that's the idea at least. So sprint one, which is what I'm going to be working on directly after this video goes up. I'm going to have the memory manager complete. I'm going to have a minimum platform abstraction layer, essentially like a platform interface that lets you use that if you're using Windows, we'll start up a Windows window. Um, obviously. And if you're using Linux, well, it's not going to be coded. But theoretically, if you wanted to code it so you could create a window in Linux, you'd be able to do that. That's what I mean by platform, or that's what I mean by the extra abstraction layer, is that you could theoretically code whatever for whatever platform you want. I'm gonna have a logger setup with 6 different trace levels. Um, I'm gonna have swap back array, circular array. I'm not gonna have a circular array, but in this sprint, but that's just ignore that. Let me cross it out. Ignore circular array. Um, yeah, swap back array. I'm gonna have a swap back array, which what that does is I can draw. What that does is if I have an array like this, 2, 3, a swap back array. If I want to remove this one, all that'll happen is this will get removed. It'll place 3 here, and then just chop this off. That's what a swap back array is. Essentially, it just doesn't care about the order of it, which, like for a entity component system, you wouldn't care about the order. You would just care that the memory is compact. Yeah, that's what a swap back array is. That's the idea. I'm gonna have a high resolution game timer and time manager setup, just because I don't want to have to. I don't want to have to set that up later, and now's a good time as any. And then I'm gonna have the math library ported. Yeah. So by the end of this sprint, I should have a window that appears and an engine that registers input. Very simple sprint. Yeah. For sprint 2, I'm gonna have a lot of the entity manager slash entity component stuff in place. It'll be like a skeleton for a lot of it because obviously I'm not rendering anything yet. So I'm gonna have a draw component that it doesn't draw anything. A material component with no materials. Just to have the skeletons in so that when I start coding the DirectX 12, when I start bringing in the DirectX 12 code, it just plug and play essentially. Um, but yeah, I'm gonna have all this entity stuff set up. I'm gonna have a camera manager, again, very simple, basically just a skeleton. And then I'm gonna have a scene manager. I'm still debating what this will look like in the final version of the engine, but for now I'm just gonna stick to what I know, which is like a scene manager, scenes with a bunch of different component managers. Yeah, that's sprint 2. Sprint 3, I'm gonna have all the DirectX 12 finished. It's gonna be initialize. It's gonna have pre-made models, and it's gonna have a draw manager that actually draws stuff to the screen. And then by the end of it, I should be able to render a single cube. Sprint 4, I'm gonna have async setup. Hopefully, I'm gonna have a basics lighting shader setup with one hard-coded light. I'm gonna have instancing setup, and I'm gonna finalize the camera manager to actually work how it's supposed to, and that's the skeleton that I set up earlier. And then maybe if I have time, I'll have frustum culling. Maybe, big maybe. Um, so by the end of this, I should have, like I said, an instancing setup, and I should be able to render a bunch of static meshes with, like I said, the one directional light. Yeah. Next up, sprint 5. You're gonna notice, by the way, the sprints as they go on, they're gonna get less and less detailed. That's because um, there's they're like I'm just putting scaffolding in place for these sprints. They're not actually hard targets because they're gonna change as I go on and blah blah blah. I'm gonna have to adapt. Yeah, these are just like targets. Um, anyway, sprint 5 is gonna be the lighting. This will be now supporting multiple lights. And it's going to have the light manager and light objects and light calling all set up. So sprint 5 is going to be a lighting week, basically, or a lighting sprint. Sprint 6 is going to be shadow setup. So I'm going to have CSM for the directional shadows. I'm going to have cube shadow maps for the point lights, and then just normal shadows for the spotlights, obviously. I'm gonna have PCF filter. It's just gonna be all the shadowing setup. I'm dedicating a whole sprint to it because it took me literal months to set up in DirectX 11. So, but I'm hoping because I have most of the code already, I can just port it over. Hopefully, fingers crossed. But yeah, that's sprint 6. Sprint 7 is gonna be texture loading. It's gonna be finishing up all the other rendering techniques, sorry, that I want to implement. It's gonna, okay, this is where I set up the light manager and have all the light culling and all that. Um, and then I put this here, clear backlog, because I assume I'm gonna have stuff not done by this point, and I want to take sprint 7 until I catch up. Um, yeah, by the end of the scene, I should have. Sorry, I've been forgetting to go over these. It's fine. Um, by the end of this week, I should have, or by the end of the sprint, I should have SSAO, tone mapping, fully textured scene, um, obviously the light manager working, and yeah, it'll be more of a catch up week or catch up sprint. This sprint 7, sprint 8 is where collision's going to be done. I don't have a full idea of how that's going to work. Probably pretty similar to Moab. I'll talk about it when I get to it. Um, but yeah, that's what it's. Sprint 8 is going to be collision. Sprint 9 is going to be audio. It's going to be particles. It's going to be a visualizer for debugging. Um, yeah, yeah, that's that. And sprint 10, finally the final sprint, is going to be where I set up the Clay library for UI. I'm going to set up a screen log for debugging. I'm going to set up um, I'm going to have stats visible at the end. I'm going to fix all the bugs. It'll be just like wrapping everything up. Um, yeah, pretty simple. Yeah. Now, finally, my sources, because I always got to quote my sources. So a lot of the project setup itself, I borrowed from the Cherno. If you haven't seen, I mean, I'm sure you've seen him on YouTube. You know, that's where I got it from. Cool YouTuber, check him out. A lot of the code was also borrowed from Travis Roman, specifically some of the some of the early core setup code is definitely a lot from him and his series on making a game engine from scratch. Go check him out again. It's a very cool series, kind of inspired me to make this engine. And then I'm going to be using a memory tracker that I got from one of my professors when I was in university. It is open source, I think, and I think I'm allowed to share it. Hopefully, too late if not. But yeah, all the credit goes to him for that. It's super cool, very cool, very useful. It's not going to be super used here because of the memory manager thing, and it's kind of all getting cleaned up in one go. And yeah, but I'm still using the memory tracker. Yeah. Anyway, that's about it. Thank you so much. I'll see you next week or 2 weeks from now. Probably next week. We'll see with the first sprint. All right. Bye bye.